In this lesson, you will know and use the formula for regular polygons. Now remember, with a regular polygon, by definition, we have a polygon that is both equilateral and equiangular. Or in other words, every side length will be the same, and every interior angle measure would also be the same. Now with a regular polygon, there are parts of the polygon that you need to be familiar with. The first is what we call the radius. The radius goes from the center to a vertex. So from right here, the center to this vertex would be a radius. And it could be to any vertex, doesn't have to be this one, but any segment going from the center to a vertex would be a radius. And then the apothem is a segment going from the center to the midpoint of a side. So right here, from the center to the midpoint of this side would be an apothem. And an apothem also creates a right angle with that side as well. So make sure you know those two terms, radius and apothem, because they'll be used to find the area of a regular polygon. So now I'm going to show you where the formula comes from to find the area of a regular polygon. Then afterwards, we'll walk you through some examples on using the formula to find the area. So looking at this picture, we see the apothem is going to be perpendicular to this first side, we'll call side 1. And notice we have a triangle that we have created using the two different radii and the apothem. And here, to find the area of just one triangle, we know the formula is 1/2 times base times height to find the area. Well, the base, we're using the side 1. So we have 1/2 times side 1, and the height is going to be this apothem. So what we have is 1/2 times side 1 times the apothem for the area of that one triangle. But notice I can create 6 triangles like that. So this first triangle, the area is 1/2 times side 1 times the apothem, or apothem times side 1. And then if we do that for the other triangles, using side 2, we now have 1/2 times apothem times side 2. And then we have same thing, but now times side 3, then times side 4, side 5, and then side 6. So we have 6 triangles here, and the area is going to be 1/2 times the apothem times the side. So if we add all those together, we're going to find the area of this regular polygon. So we take 1/2 a times s1 and add up all of these together. Now from here what I can do is I can factor out a 1/2 and an a, because notice every term has a 1/2 and an a in common. So I factor that out, and I'm left with, in parentheses, the s1 plus the s2 plus s3, s4, s5, and s6. So now notice that if I were to add up all of the sides, side 1 plus side 2 plus side 3 plus side 4 plus side 5 plus side 6, then that gives me the perimeter of this polygon. So I have 1/2 times the apothem, then times that by the perimeter to find the area. And that is my formula to find the area of a regular polygon. Now using this formula, let's say the side length was 4, and then the apothem here was 5. And the question is to find the area of this polygon. Well, the formula is 1/2 times apothem times perimeter. The apothem here is going to be 5. So the apothem is 5. It's the distance from the center to the midpoint of this side. And then we need to find the perimeter. Well, we're told that this is a regular polygon, meaning every side is the same length. So if one side is 4, then the other sides are also 4. So if we have 6 sides that are each 4 units long, the perimeter would be 6 times 4, which would be 24. So plugging the numbers in, I have area equals 1/2 times 5 times 24, which when you multiply would give me 60. Here's another example where we do not know the apothem or any side length. But what I do know is the radius. So the radius is given to me as 8 times the square root of 2. Now the question is, can I use that information to find the apothem and the side length? Well, notice here we have a square. And a square, by definition, will have angles that are each 90 degrees. So with that being said, this angle down here in the bottom left is 90 degrees. And with the radius will cut in half this corner angle. Meaning if the whole thing is 90, then it's going to bisect that angle, where now I have two angles that are 45 degrees each. So this angle is 45 degrees, which would also make this other angle up here to be 45 degrees as well. So what we have is a 45, 45, 90 triangle. And remember, with a 45, 45, 90 triangle, the legs will always be the same, and then I can take one of these leg lengths, multiply it by square root of 2 to get to the hypotenuse. So what times square root of 2 would give me 8 times square root of 2? Well, that's just going to be a 8. So this side length would be 8. And then the apothem would also be 8, because the legs are the same for a 45, 45, 90 triangle. So if this leg is 8, then this other part is also 8 over here on this side. So the entire length of the side would be 16. So every side would be having a length of 16. So using that information, the apothem is 8. Plugging that into my area formula, I'd have 1/2 times 8 is the apothem, and the perimeter would be 16 times, there's 4 sides, so the perimeter would be 64. So I plug those numbers in, and I get an area of 256. Here's another example with a triangle. And in this case, we are told the apothem, but we do not know the side length. So we'd like to find the radius, and then we need the perimeter, and our objective is to find, ultimately, the area. Now with this picture, we have an equilateral triangle, and every angle is the same with a regular polygon. And a triangle is 180 degrees, so every angle would be 1/3 of that 180, which would be 60. So this angle is 60 degrees, and every other angle is also going to be 60 degrees. But this radius is going to bisect that angle, creating two angles that are both 30 degrees. So this angle right there would be 30 degrees. And we can use now this triangle to find the radius, because we have a 30, 60, 90 triangle. Here's 30 degrees, up here would be 60, and then the other angle is 90. And we know with a 30, 60, 90 triangle that everything is based off the side across from the 30-degree angle, which would be this side over here. So everything is based off this side. The hypotenuse is times 2, and then the other side is times square root of 3. So down here we have 4 square root of 3, and then the radius would be 8. So then using this information, I can then plug numbers in, where the apothem is already given to me as being 4, and then the perimeter I can find, because if this is 4 square root of 3, then this other half is also 4 square root of 3, so the entire length of the side would be 8 square root of 3, which means the perimeter would be 3 of those sides put together, so 3 times 8 would give me 24 square root of 3 for the perimeter. And then plug 24 square root of 3 in to the formula along with the apothem of 4. And so when we plug those in, we would have 48 times the square root of 3. Here's one last example. And in this picture, we have a regular hexagon, and we are given the radius to be 4. Now to solve this one, I first need to know what is this angle measure down here in the corner. And once we find that, we can then calculate the apothem and then the side length, which can then be used to find the area. Well, remember back on how to find the area of all of the angle measures added together for a regular polygon. What we do is we take n minus 2 times 180. So the number of sides of the polygon, subtract that by 2, then multiply that number by 180. So we have 6 sides, and we put 6 in for n, so we have 6 minus 2 times 180. So when you do that, you're going to get 720 would be the sum of all of the interior angle measures. But there are 6 angles, so to find one angle, we divide that by 6, which gives me 120 degrees for the big angles. So right here is 120, 120, 120, and then all of these would be 120. Now down here, we want to know the angle measure of this triangle right there. Well, this radius cuts that 120 degree angle in half, making that angle 60 degrees. So this is going to be 60 degrees, which makes this up here 30 degrees. And with a 30, 60, 90 triangle, everything is based off the side across from the 30 degree angle, which is going to be over here. So this is across from that 30 degree angle. Now once we have this, the hypotenuse is times 2. And so we can conclude that this right here would be 2, because 2 times 2 gives me 4. And then the other side is multiplied by square root of 3. So that apothem would be 2 times the square root of 3. So the apothem is 2 square root of 3. One side length we have from here to here being 2, and then it's going to be the same for that part as well. So we have 2 and 2, meaning each side would be a length of 4. And there are 6 sides, so the perimeter would be 24. So we plug that into the formula of 1/2 times the apothem times the perimeter, and we're going to get our answer of 24 times the square root of 3. And that concludes our lesson for today. We will see you next time.